Welcome back. Today we're covering the programming paradigm that makes Jack feel new. Object-Spatial Programming, or OSP, will build up the ideas one at a time and end with a small runnable program that ties every concept together. Here's the shift. In conventional programming, you pass data into functions. The function is the fixed thing, and data flows in as parameters. In Object-Spatial Programming, the graph is the fixed thing, and computation travels to it. A walker moves through the graph and runs at each location it visits. Small change in framing, big change in how programs are shaped. OSP adds 3 archetypes on top of familiar objects. A node is a location in the graph. It holds state and reacts when a walker arrives. An edge is a typed directional relationship between nodes. Edges can carry their own data too, like the data follow happened. A walker is a mobile unit of computation. It carries its own state and reacts to specific node or edge types as it travels. 2 reasons this matters. First, natural graph modeling, social networks, knowledge graphs, workflows, state machines. Problems that are already graphs stop needing translation. Second, AI agents fit naturally. A walker has state, moves through an environment, and reacts to what it finds. One design choice OSP asks you to make: where does behavior belong? Behavior on the node says, this location responds to visitors. Behavior on the walker says, this agent knows how to handle certain nodes wherever it finds them. The same effect can often be written either way, and the choice communicates intent. Nodes are for behavior tied to place. Walkers are for behavior tied to purpose. A walker is a different kind of thing from a function. A function is called with arguments and returns a value. A walker is spawned onto a starting node, decides where to go using visit, executes at every location it lands on, and reports results back as it goes. A function runs in one place. A walker runs in many. Let's declare the shape of the graph. 3 node types: profile, tweet, and channel. Each has a couple of typed fields. Profile has a username. Tweet has an author and content. Channel has a name. These are just data containers for now. Behavior on the nodes comes in a few slides. Edges are declared the same way. 4 edge types. Post, member, and channel post are markers, no data, just relationships. Follow is a typed edge that carries its own field, the date the follow happened. When you traverse along a typed edge later, the endpoints come back with the right type automatically. Time to build a small graph. 3 profiles: Alice, Bob, and Carol. The graph lives only for this run. Alice follows Bob with a typed follow edge. Bob follows Carol. Alice posts 1 tweet with a post edge. Bob posts 2. Alice joins a channel called Hangout with a member edge. All of this lives in a with entry block. Now the behavior. Each node type gets an ability that fires when a described graph walker arrives. It's a can block, tied to a specific walker type on entry. When the walker lands, the node introduces itself in its own voice. Profile prints its username. Tweet prints its author and content. Channel prints its name. The walker just triggers the ability. The node does the talking. Here's the walker, 1 ability, tied to profile entry. Every time it lands on a profile, it schedules 3 visits: outgoing edges to tweets, outgoing edges to channels, and outgoing follow edges to other profiles. Notice the walker itself doesn't print anything. The nodes it visits do. Now watch it move. Spawn the walker at Alice. Tour fires at Alice and schedules 3 visits. The walker fans out concurrently to Alice's tweet, Alice's channel, and Bob. At Bob, Tour fires again, recursively scheduling Bob's tweets and Carol. Carol has nothing to visit, so the traversal ends. 1 spawn, 3 fanouts, 7 nodes touched in total. Everything you've seen fits in one runnable file. The 3 node types with their greet abilities, the 4 edge types, the describe graph walker, and this with entry block that ties them together. The file path is on screen. Grab it, run it, and watch the walker tour the graph. And this is what you see. Alice's profile prints first, then her tweet and her channel. Then Bob prints, followed by his 2 tweets. Finally, Carol. 1 walker, 1 visit rule per type. 3 levels of fan out, end to end. That's OSP. Nodes hold state, edges carry relationships, walkers travel and act. See you in the next one.